Assalamualaikum and hi. In assignment 2 for vision system, we have 3 members, Nur Awani binti Samad, Ifah Izzati binti Khalid, and I, Siti Aisyah binti Muhammad Khairun. Okay, for introduction, recycle is to use the thing again but in a different purpose. Recycling is the important part for environmental and economic aspects because to maintain an effective recycling system and to separate the recycled material are needed. CNN is a class of deep neural networks and most commonly applied to analyze visual imagery. The pre-trained models that have used in this project are CNN, VG16, and ResNet. VGG16, also known as OxfordNet, is a convolution network architecture that is 16 layers deep and can load a pre-trained version of the network trained and on more than a million images from the ImageNet database. ResNet is to solve the problem of vanishing gradient in deep neural networks by allowing this alternate shortcut path for the gradient to flow through.
Assalamualaikum and a very good morning. My name is Nur Arwani binti Samad, metric number AE170136. Now I will continue to explain about the methodology of our project. In task 1, we use convolutional neural network CNN. It is a deep learning algorithm which takes an input image, assign importance of various objects in the image, and able to differentiate one from another. It also reduces the image into a form which is easier to process without losing feature. For task 2, we use pre-trained model of BGG16. It focuses on having convolution layer of 3x3 filter with stripe 1. It always uses same padding and maximum pool layer of 2x2 filter with stripe 2. It has a large network and approximately has about 138 million parameters. Last but not least is we use pre-trained model ResNet for task 2. It is designed to enable hundreds or thousands of convolutional layers. It stacks up identity mapping, layer that has no function, and skip over them and reusing the activation from previous layers. Skipping will compress the network into a few layers, which enable faster learning process.
Assalamualaikum and hi, my name is Ifah Izzati binti Khalid, metric number AE170077.
I will show you the demonstration how to design the CNN model in the Google Colab. So the first step is to connect to the Google Drive. Just push this button to connect to the Google Drive and it will give the links to our Google Drive and have to paste it here. Then the step 2 is to feed the dataset directory. We have to make sure that this thing is same with our Google Drive file. Then the third step is to create train and validation data. Also, we have to make sure this thing is same with our file in the Google Drive and just push this button and the result is here. Then import the relevant library that used to do the design the CNN model, and the step 4 is to construct the CNN model. Just push this button and the output will be out here. Then step 5 is to pre-process the input data. Then the step 6 is to start the training process. Here we use the import stance and the result is here. This will show the loss and accuracy of the train, and this will show the loss and accuracy for R. So the meaning of 1.0000 is 100%. And then the step 7 is to plot the outcome. The result is shown here. And then step 8 is to feed the sample image to observe the which pair of can is the dominant. So the first image is to when we take a picture, can stay and pad further backward. So the image show like this. Then the result is this image is 100% can and 100% pad. And the second image is the pad and cat. Pad and can still same distance from the camera screen. And the image is like this. And the result is this image is 100% can and 100% pad. And then the third image is the pad stay and can move further backward. The image is like this. So the result is this image is 100% pad can and 100% pad. For the demonstration of a pre-trained model, here we use a VGG16. The step is almost the same when we want to design the CNN model. So for the first step is to connect to the Google Drive, and the second step is feed dataset the directory, and step 3 is to create thread and validation directory, and upload the library used. Then the step that is different from the CNN model is to construct a pre-trained model with VGG. We use this code to construct the pre-trained model with VGG, and here is the output. And also here's the output. And then the step 5 is the pre-process the input data and start the training process. Same with the CNL model, we use the same epoch number, and here is the result. This is the loss and accuracy of the twin, and this is the loss and accuracy for the bar. And then the step 7 is to plot the outcome. And here is the figure we already plot, and this is the outcome. For the second pre-trained model, we use the ResNet, and the step is the same with the VGG16 and the CNN model. First step to connect to the Google Drive. Second step is to feed the dataset directory. Step 3 is to create train and validation data directory and import the library. And the different thing is to in the step 4, which is to construct a pre-trained model with ResNet. This is the coding to construct the pre-trained model with the ResNet. And step 5, same, pre-process the input. And then step 6 to start the training process, we use the same approach with the CNN model and VGG16. And this is the outcome. And then to plot the outcome, and the outcome will be like this.
This is the result of task 1. The picture shows the construction of CNN model. This is the parameter from the CNN model that was designed, and this is the outcome. The picture shows training and validation accuracy of CNN model. It has average validation of 0.9533 and average training with 1.0. For training and validation loss, it has average validation of 0.1362, while it has average training 3.3759. For task 1, we need to find the optimal model which will be named M1. Then 3 pictures will be fit into the model M1. This is the outcome of the picture that was fit into the M1 model. As shown in the result, this image is 100% can and 100% pad, which is correct that it has one pet bottle and one can. Then when the can and the pet bottle was put side by side, it also show 100% can and 100% pet. Lastly, when the can was put at the back and the PET bottle was put in front, the image is also 100% can and 100% PET. Then, for task 2, we need to construct a pre-trained model with VGG16. This is the outcome of the VGG16 pre-trained model. The training and validation accuracy of VGG16 is, it has average validation of 0.9748 and average training of 0.9730. For the training and validation loss, it has average validation of 0.05 and average training of 1.0008. Next, we use ResNet pre-trained model, and this is the outcome, which is average validation is 0.4424, average training is 0.9408. For training and validation loss, it has average validation of 0.4424 and average training of 0.8413. That's all from me, and now I will pass to Aisha to continue for the conclusion. Thank you.
The conclusion of for this project. In this project, our group have used the 3 different pre-trained model, which is CNN, VGG16, and ResNet. The students be able to learn on how to do a convolution neural network using Google Colab, and also run a algorithm, which is programming command on Spider in Anaconda software. Combining transfer feature which are VGG16 and ResNet from multiple CNNs could improve the classification accuracy. We learned how to obtain the result using VGG16 and having higher accuracy as compare the result of tuning without pre-trained model. Thank you.